By the way, Brother Ted, I like The Spacious Firmament. It's a beautiful creation song about astronomy. And the melody, the tune, Franz Haydn, I mean, he's quite the composer there. It's a great hymn. So most people don't seem to know it, though. Well, good evening. It's good to be here again. We looked at human history recorded in the Bible, and we looked at natural history recorded in the Bible last night. Today we're going to look at just 3 different areas of science in which I like to say they are, this isn't working. Why not? We're stuck on this thing. We're going to look at some, what I call rather creative claims by evolutionists. When the evolutionists come up with some of their explanations, I think that they can be pretty creative in what they come up with. And so I've got 3 that I've chosen tonight. A couple of them you're probably familiar with. I don't know what that even is. There we go. That's fine. Is that? Yep. We're good. I don't know where that sunset came from. It was pretty, but it was sort of a little overbearing. So we're fine now. Okay. So we're going to talk about some creative claims by evolutionists. And I said we're going to look at three different ones. So the first one is that birds are dinosaurs. How many have heard this? Yeah, it's not been around that long since the evolutionists literally just come out and say birds are dinosaurs. For quite some time, they've said that the birds evolved from dinosaurs. But you jack up the rhetoric to the point where now we're told that birds are dinosaurs. Now this bird behind me here, that is not a real creature. It's a make-believe creature, but it's a fabulous picture, isn't it? It's really cool. I'd like to see one, although I don't know about those teeth. But birds are dinosaurs is what we're told. Now, if you go to the Chicago Field Museum, anybody ever been to that one? The man last night was saying that he was at the New York Natural History Museum. I always, if I have the opportunity, like to go to the Field Museum, the Natural History Museum in a big city, to find out the latest. Like I had mentioned, one of the things that's always good to do is take some pictures of some of the presentations and then come back in a couple years and see what has changed, because so much of it changes. And again, I'm not critical of that. That's the nature of science. You learn new things, you change the presentation. What I am critical of is how critical those that present those things are of anyone who would question it. Because the chances are it's going to change within a few years. In any event, at the Chicago Field Museum, if you go to the dinosaur exhibit, they call it the dinosaur exhibit, you'll read over the doorway as you go in, birds are dinosaurs. And this particular display that was especially built for children, although anybody could do it, was showing how it is that birds are actually dinosaurs. They talked about the closest relative to the birds today was the dromaeosaur. And so here on the bottom, you see it says the dromaeosaur skeletons share many things in common with those of birds. And then there's a little help panel, and you push the red button and it lights up a portion of the skeleton. And so you're supposed to be able to see that birds have open hips like the dromaeosaur, they have a wishbone, all these different things, where the dromaeosaur, this dinosaur, is actually a modern day falcon. I mean, they're literally saying that a falcon is a dromaeosaur, but I guess it's got feathers and a few different things. But hey, they're virtually one and the same. That's the way they present it. Well, One of the things that you'll virtually never hear of, I've never seen it discussed anywhere, and I try to keep my eye open for these things, is if birds are dinosaurs, how did they get the respiratory system that they have? Because a bird, an avian respiratory system, is dramatically different from a dinosaur or reptile or mammal. They have what we describe as a flow-through respiratory system. I'm talking about their lungs and how the air goes in and how the air goes out. Their respiratory system literally is a flow-through system where you and I, right now, everybody take a deep breath and hold it. Okay, now let it out. So the air went in and out the same place. And some of the air that you just took in mixed with the air that you blew out. That's a bellows system. It goes in and out like a bellows. But a bird, it flows through. It doesn't go in and then out. It flows through. So we call it a flow through versus a bellows system. The way that the bellows system works is you've got a muscle, a diaphragm, it's called, and your ribs are curved like here, and that diaphragm is spanning the rib cage underneath. And when you take a breath, you contract that diaphragm so that instead of being curved like this, it flattens out. It shortens up and it flattens out. When that happens, it expands the rib cage and you suck air in. And then you relax and then the air comes back out. So the diaphragm is crucial for you to be able to breathe this bellows style in and out kind of respiratory action. Well, not only does the bird have this flow-through ventilation system, respiratory system, as opposed to the bellows system, it doesn't even have a diaphragm. Now, remember, you've got to have a diaphragm to breathe, to have this in and out. So what has to have somehow happened, and apparently it happened instantaneously, you've got the loss of a diaphragm, and you've got the pipe work completely switched around so that instead of in and out, it flows through and the diaphragm is gone. Here's a picture of a bird, and what if I can get a, nope. Here's that is not working. Here's the trachea, the air goes in here, and it doesn't go immediately into the lungs, it flows into these air sacs in the back. And then when the bird exhales, that air then goes into the lungs. When the bird breathes again, more air comes into these sacs. The air from the lungs goes into another sac, and then when it exhales, that air goes out, and it flows through like this. All these air sacs are in addition to the lungs where the actual gas exchange occurs. Here's a diagram of it. So the air comes in, it goes into an air sac. When the bird exhales, it goes out into the lungs. From the lungs, it goes into another air sac. When the bird breathes in again, it goes in, more gets pushed out, and it goes out like this. So the air just flows over the gas exchange tissue. Now here is a bellows-style lung. Here's the chamber. The diaphragm would be down here. That chamber expands. It gets bigger. Air sucks in. It exchanges the carbon dioxide and air and oxygen in the alveoli, and then it goes back out. All the while, you're mixing the air that the oxygen was removed from with the air that is now carbon dioxide rich, and you're mixing it together. So our respiratory system is much less efficient than a bird's respiratory system in the gas exchange. One more little chart here, so you hopefully by the time you read this one, you'll get the sense of what's going on. Okay, here's the bird. He's going to breathe in. The air is going to go all the way down here to the posterior air sac. Then when it exhales, the air moves from that posterior air sac into the lungs. Some of the air that was in this anterior lung then goes on out. When the bird breathes in again, more air comes in this way. The air that the oxygen was depleted from goes into the anterior air sac. And then when it exhales, that air goes out, new air comes in, and it continues to flow like that. This is dramatically different from the respiratory system of a dinosaur. I've never heard the evolutionists deal with this. If you ask them, that's interesting that these birds are dinosaurs. How did they get these airflow lungs as opposed to the diaphragm bellows lungs that the dinosaurs have? I've not heard any explanations for that. And so it's pretty imaginative to say that just because some of the bones in a bird's skeleton are similar to theropods, they're called, a group of dinosaurs that stand up on their hind legs, and their pelvis is similar to the bird's pelvis, that the birds actually are dinosaurs. But that's what we're told. The next creative claim I want to consider is the claim that Lucy, not Desilu, Lucy, Lucy, the ape woman, is our great, I don't know how many greats, grandmother, the mother of the modern human race. Now let me tell you something about Lucy. Lucy is the same kind of a term that man is. Man, capital M. When we say man or mankind, we're talking about human beings, right? Male, female, different races and everything. We're just talking man. Lucy is the same kind of a term. Lucy is referring to a group of creatures called Australopithecus afarensis. And so when they say Lucy, they're not always just talking about this one particular skeleton, but an awful lot is made of that amazing skeletal find that they named Lucy. Whenever you go to a museum or look in a textbook, when they show you Australopithecus afarensis, they always make them look very human, except, they're hairy. Sometimes they'll have pensive looks, like they're dreaming about where they're going to go next Tuesday. Or, they make them look very human, just covered with hair. This is a little more realistic representation, I would say, of Australopithecus. This was at the Natural History Museum in D.C. I was just at the Smithsonian a little bit ago. And there you can see it's an ape. It's an ape head. It's an ape nose and everything else. I think this is probably a much better representation of what Lucy really did look like. But what about this Lucy, this amazing fossil? It was discovered in 1974 in Ethiopia. And when they found it, they claimed that its lower body was human-like, but its upper body was more ape-like. And therefore, this was the beginning of an ape-like creature that could walk around on two hind legs. Now, what's so important about that in the evolution of humans? Well, now you've got your hands free to make tools and do all the kind of things that lead to humanness. So this was a vital step in human evolution, standing up. So you need a transitional form between just a gorilla or a chimp that now is comfortably standing up and living on the ground for the most part and becoming then human. Well, okay, the lower body is supposed to be human-like. How about the feet? I mean, the feet are a very, very crucial part of being able to stand up, an arched foot and the big toe being the way it is and so on and so forth, for balance and so forth. Well, Here's the amazing find. It was a skeleton 40% complete, which was just unheard of. Before, you would find a bit of a skull or a finger or something, but this was fantastic. 40% complete skeleton. It was wonderful. However, as you can see, there were no feet. There were very little bones, but there was some bones, and an important part of it was the knee joint. Even from that much of a skeleton, they could tell that this creature was somewhat bow-legged, okay? And I'm not going to explain a whole lot about the importance of that because we're going to see a video in a little bit, and Dr. Menton is going to explain how important that is. But this fossil did appear to have legs that were somewhat bow-legged, all right? And that is human-like. However, there are several apes that are also bow-legged. So just because it was bow-legged doesn't mean it couldn't be an ape, all right? It's only humans have bow-legged. And of course, no feet were found. So, move forward 4 years. And the Laetoli Trail was a huge discovery. As you can see there, it's footprints in ash that have turned to stone, okay? Just like we find dinosaur footprints in mud that turns to stone or volcanic ash that turns to stone. These were footprints that were turned to stone in volcanic ash. And this volcanic ash was dated to be in the neighborhood of 3 to 3.5 million years old. And so we've got what looks like human-like footprints in 3 million year old ash. Well, it can't be a person. Who was it? It was Lucy. This was the discovery that was needed to then propose that, yes, you see, here's this Australopithecus afarensis that walks upright, and here we don't have any foot bones, but here are footprints of this creature walking around on 2 feet. Now, one of the really fascinating things about this is that within those footprints, here off to the side, you notice the little ones here? Here's adult footprints, and then here are little footprints. The trail continues, and the little footprints end up getting into the big footprints, and the little footprints are in the big ones. So the little creature, we'll call it at this point, begins to get right in mom or dad's footprints and is following them in the mud. Well, maybe an ape would do that. I sure know a little kid would do that. So, we've got these footprints. The problem is, they're found in Tanzania. Remember, Lucy was found in Ethiopia. You know how far Tanzania is from Ethiopia? It's 1,000 miles away. And yet they propose that, but these footprints were made by, now they're not saying that it was the individual Lucy, but these are the one and the same species with nothing more than half a skeleton and then footprints in the mud. But that was now the proposal. We've got feet that are human-like to match up with Lucy's skeleton. But not only is this distance somewhat of a problem, these footprints are literally exactly like modern footprints. So it's not a matter of, okay, you've got sort of like this ape that evolved some feet that were becoming rather modern. You've got an ape with human feet, literally. If you look at that footprint there, the large one, a human footprint would look exactly like that in the mud with a little erosion. Well, it wasn't until then 2011, so this was quite a span of time. We're talking 1974 until 2011 that what were considered to be Australopithecus afarensis foot bones were found. And the thing is, the foot bones were rather minimal, okay? It was a toe bone, one toe bone. There it is. And papers were written about how this particular bone, has an arch to it, which human metatarsals will have. These bones were found in the area and in the quote-unquote strata that the Laetoli footprints and these other fossils are found. So it's then claimed that these are Lucy, I shouldn't say are, that this is a Lucy metatarsal, and it demonstrates that Lucy had human-like feet, therefore walked upright, and they matched up with the footprints and the claims that they were making that Lucy was sort of half human, half ape. It takes a lot more than human-like feet and bow-legged knees to walk upright. In fact, the most important part of walking upright is the pelvis. So what kind of a pelvis did Lucy have? I'm going to show you a little video clip because Dr. Menton, the late Dr. Dave Menton, was with, he was an anatomy professor at the University of Washington in St. Louis Medical School for some 30 years. And so his knowledge of anatomy is unparalleled. And he then, as a creationist, went and started working with Answers in Genesis. And unfortunately, just a few years ago, we lost the brother. But he did a video on the Lucy bones. And the name of the video is Lucy, She's No Lady. Another thing that's interesting is they assume that Lucy is a female because the skeleton is small. Well, you can't tell that for sure Lucy is a female just because it's small. There's a variety of sizes, but at the time they were quite certain that little meant female and big meant male. Anyway, whether she's female or male, we can't be certain. That's the big thing. But I'm going to show you this little video clip, and Dr. Menton is going to explain the importance of the pelvis.
The big problem, however, are the hips. As you know, all ladies are concerned about that, and so I would think Lucy is too. And let's look at these hip bones. There are really three bones that fit together to form the whole pelvis. I brought along the right piece of the human pelvis here. Fits right down here. And they're made of three different bones: the iliac part, the pubic part, which is right in front here, and right here is the ischium. These are the ischial tuberosities, and you are all sitting on your ischial tuberosities right now. That's what's supporting the weight through the gluteus maximus. Now, there's a distinct hip for apes and humans. And as far as I know, no overlap. You can't confuse an ape hip with a human hip. What's the big difference? Well, let me bring up a drawing that'll help to illustrate this. If you look at the top, that's a chimp. And at the bottom, that would be human. Notice the iliac blades of the human go front to back like this. It almost looks like a steering yoke on an airplane when you get them both together, right? As you look at it, isn't that sort of like a steering yoke on an airplane? See the handle here and the handle here upside down?
It's that surface right along there that matters.
Whereas the ape, the iliac blades flare out laterally.
Versus that.
So if I put this in place, in the human, this blade would be here, and the ape, it would be out here. Got the picture? This versus this. Now, why is that important? You need to have it this way if you're going to walk, as humans walk. Why is that so? My students tell me that I was at one time or another able to use almost every item of clothing on my body to illustrate things. Handkerchiefs can make muscles, and if we have a muscle that attaches to the iliac blade here called the gluteus medius, and that muscle comes down from here to here, right across there, and attaches to this bump on the femur. Now that's important because when we lift our left leg, Think of an articulated dowel now. If you lift a leg, what's going to happen? If these are articulated joints at the hip, this hip's going to fall, isn't it? Lift the left leg, the left hip will fall. If I lift the right leg, the right hip will fall. What keeps this from happening? When I lift the left leg, the muscle that goes between here and here tightens up, and it keeps that from happening. See that? It's attached here. So if you don't have this orientation of the iliac blade, you cannot keep your posture as you walk perfectly even. Once again, you have to throw the weight back and forth to overcome this. Now on apes, the blade is like this. I've exaggerated a bit. The same muscle, gluteus medius, comes over the backside now. Notice that? It's going down the back. And apes have a center of gravity in front of their knees. They want to fall over forward anyway. And so this same muscle keeps them from falling further forward. So you can look at the pelvis and tell whether you're looking at an ape pelvis that cannot walk anything at all like we do, or a human pelvis. The big question is, what kind of pelvis does Lucy have? Well, Stern and Sussman said, the fact that the anterior portion of the iliac blade faces laterally in humans, he's talking at, this is facing lateral out here rather than over, but not in chimps is obvious. The marked resemblance of Lucy to the chimpanzee is equally obvious. So you get the picture? The creatures like Lucy have the ape orientation of the iliac blades. Now, what are the evolutionists going to do about that? You're not going to believe this.
They get creative.
Nova, have you heard Nova? There was a PBS Nova series in which Dr. Owen Lovejoy, a very distinguished, famous paleoanthropologist, was involved. And he's looking at Lucy's skeleton here, and he's lamenting the fact that the hips are all wrong. They're supposed to be human-like hips, so you can walk the way the Laetoli footprints showed she walked, but they don't look like human hips, they look like ape hips. What to do about this? Watch it. You'll get a big kick out of this.
The ape that stood up, it was a revolutionary idea. We needed Owen Lovejoy's expertise again, because the evidence wasn't quite adding up. The knee looked human, but the shape of her hip didn't. Superficially, her hip resembled a chimpanzee's, which meant that Lucy couldn't possibly have walked like a modern human. But Lovejoy noticed something odd about the way the bones had been fossilized.
When I put the two parts of the pelvis together that we had, this part of the pelvis has pressed so hard and so completely into this one that it caused it to be broken into a series of individual pieces which were then fused together in later fossils.
So you see they were broken and they don't fit together properly. They did speculate in the program as to exactly who was responsible for breaking the hip, and current scientific evidence suggests perhaps a deer stepped on it. Here you can see a deer foot stepping on the bone. Isn't that a bummer? Let's see where it goes from here.
This has caused the two bones, in fact, to fit together so well that they're in an anatomically impossible position.
The perfect fit was an illusion that made Lucy's hip bones seem to flare out like a chimp's. But all was not lost.
This is a power saw, friends. You may want to put your goggles on.
Lovejoy decided he could restore the pelvis to its natural shape. He didn't want to tamper with the original, so he made a copy in plaster.
Notice he's removing whole parts, not just cutting.
He cut the damaged pieces out and put them back together the way they were before Lucy died. It was a tricky job, but after taking the kink out of the pelvis, it all fit together perfectly, like a three-dimensional jigsaw puzzle.
Look how perfect. You can read a newspaper through the hole.
As a result, the angle of the hip looks nothing like a chimp's, but a lot like ours.
Yeah, now, this is what we call science. You can teach this in the public schools, but you can't criticize it, because if you do, that would be religious.
So you understand that that was part of a TV documentary on that Nova series. And it's astounding that they presented it like, well, of course, and didn't even blink at the idea of just changing the bone structure all around to make it fit the way they wanted it to fit. But this is how far we've come in just accepting what the experts, tell us, and how creative that they can become in making certain that the bones fit correctly. I'm going to read a little bit more. I hope I can advance this now.
The big problem, however...
There we go. Okay. I'm going to read a little bit from a New York Times article, just came out a couple days ago, January 31st. In 1974, they found Lucy. So last year, there was quite a lot about the 50th year anniversary of finding this important fossil. And there's still been some carryover from a lot of the work that was done or published last year. But here's a little blurb that I just found. More than 3 million years after her death, the early human ancestor known as Lucy is still divulging her secrets. In 2016, an autopsy indicated that the female Australopithecus afarensis, whose partial remains were found in Ethiopia in 1974 and is considered the most complete hominin fossil found to date, died from a fall out of a tree. Okay. 7 years later, a virtual reconstruction of her leg and pelvic muscles, which are not preserved in fossils, revealed that she stood about 3.5 feet tall, weighed between 29 and 93 pounds, and was capable of standing and walking upright, similar to modern humans. And this was published in the journal Current Biology. They said that she was capable of running too. So even though more and more objections arise against it, the response is to just get that much more firm and specific and certain about not only can she walk, we know what happened to her, how she died, and that she can run. And yet the actual evidence demonstrates that this creature was an ape from waist up and waist down. Her fingers, the fingers that they have found, are very curved. What kind of a creature has curved fingers? Knuckle walkers. Her arms are much longer than normal. I mentioned about the bow-legged knees, and why is that important? Well, just like he was pointing out that if your hip doesn't lock in on the side and you lift your leg up, you'll go over like that. Well, the other thing will be if your legs are straight up and down, again, you're gonna be sort of walking like one of those little wooden doll things. So you need bow legs, that helps, and you need the hip orientation to keep from doing this. And where have you ever seen this? A gorilla, a chimpanzee, that's the way they walk. And they have to walk that way because of the pelvic structure, the knee structure. Everything about the Lucy skeleton demonstrates that that's how Lucy walked. Why the bow legs? Well, the apes that we know of today that have bow legs spend a lot of time in the trees. And they're hanging like this, and they're walking in a straight line on what? On the limb of a tree. So their anatomy fits their environment, their arboreal environment, a tree environment. So that's the status of Lucy. When you'll hear about her being the mother of the modern human race, just recall how much imagination has gone into those proposals, how much creativity has gone into coming up with that explanation. Finally then, the third thing I wanted to share is about a proposal that there were a group of people called the San people. They used to be called Bushmen in South Africa. And it's proposed that they were quite the paleontologists in their day. It's pretty amazing that they have found cave drawings, cave paintings, in caves where the bush people, the San people, lived 200 years ago. They drew all these different animals and people and things on the walls. So here's a title of the article that was published just in September of last year in the SmithsonianMagazine.com. A remarkable 200-year-old rock painting may depict a strange animal that went extinct 250 million years ago. And it's interesting because other articles you read say 210 million years ago. You know, one of the things that just frustrates me, to be honest, is how just millions of years get thrown around and they just don't matter. 210 million years, 250 million years, what's the big deal? You know, well, that's a 40 million year difference. I think that's significant. But not when we're just sort of throwing numbers around to propose ideas about what came from where, when. Well, you can read this for yourself, I know, but I'll read it as well. This is out of the Smithsonian Magazine talking about this article that was back in September. Between 1821 and 1835, the San people of South Africa painted an exhilarating battle scene on a sandstone cliff called the Horned Serpent Panel. Among the depicted warrior spears and recognizable animals is a mysterious addition. A tusked creature with a long curved body and a polka dot skin that doesn't resemble anything living today. Now, paleontologist Julien Benoit has suggested that the horned serpent might depict the long extinct Dicynodont. His study was published in the journal PLOS One. We actually looked at an article from that journal last night as well. So he's proposing that that animal that they couldn't identify, it's not anything today, actually is an extinct animal, has been extinct for over 200 million years. Now, this is the actual photograph of that horned serpent panel. It's pretty tough to see what's there, but here is, you can see like an antelope or something there, and here's another one. The Dicynodont is right here, and we're going to close in on it. And then there's another animal here. This isn't the entire panel, so we're going to zoom in a little bit. And here's the Dicynodont. See the spots on its body. And one of the important things are the tusks that they're showing coming out of its head. So there it is. So how do we make any sense of this? Well, this is what the artists, and they've got ways of doing this, I suppose, come up with to show what it probably looked like originally. So this particular illustration was made in 1930. I'm sure actually that rock wall painting was in better shape than it is even now. And the Dicynodont there is in the lower left portion of the painting. So there it is. There's its tusks here. But notice we've got, I don't know, is that a porcupine? We've got some other animals here, a deer. We've got a large animal, maybe that's also a giraffe. I'm not sure what all these particular things are. But what is important to note is what's going on here. They're hunting these creatures, right? So how do they explain this creature that is supposed to be extinct for 200 plus million years, there on the rock painting with all the other animals that the Sand people were hunting? Well, Benoit explains, this work supports that the first inhabitants of southern Africa, the San hunter-gatherers, discovered fossils, interpreted them and integrated them in their rock art and belief system. So, after they had a good hunt and had nothing to do, they went out and gathered fossils and uncovered the bones. You know, have you ever watched programs where they do fossil digging and the meticulous involved, what goes on, and then you've got to put the bones together and then determine, the shape of the animal and all of that. Well, the Sand people, some 200 years ago, were digging up fossils and doing this. This is a serious, straight-faced proposal. Here's one of the fossils of the head of a Dicynodont that's uncovered there in the area. It's a pretty neat fossil. You can see the tusk here, part of its head. But you all realize what's involved in digging fossils and putting the bones together to form an articulated skeleton. This is an artist's illustration of one type of a Dicynodont. There was a lot of them. You see, they say that this creature is, let's see, it wouldn't be our mother like Lucy. This is our, I don't know how many generations back, grandfather, because this is the ancestor to mammals. From this creature came all the mammals, and this creature lived during the days of the dinosaurs, actually went extinct before the dinosaurs. So during the days of the dinosaurs, as they were becoming birds, the mammals were evolving and filling the world with mammals, and then the dinosaurs died out, and we know the rest of the story. So here again, we've got an illustration of what these Sand people were painting on the cave walls, a hunt. And part of the creatures that were involved in the hunt was this Dicynodon. It might not be. It may, who knows, maybe it's something else. We know it wasn't a walrus or something like that. This is in the interior of South Africa. So a Dicynodon is as good a guess as anything. But, is there a more likely explanation than the Sand people, the Bushmen of Africa, engaged in paleontology 200 years ago? Well, the Word of God tells us that God made the beasts of the earth. That would have been Dicynodons, as well as walruses and antelope and all the other animals on earth, after their kind, and the cattle after their kind, and everything that creeps on the ground after its kind. And God saw that it was good. Then God said, "Let us make man in our image," indicating that these land creatures, beasts of the earth, and man were created on the very same day. And the explanation is that those Dicynodons were there at the same time man was there, and they drew them on the cave walls. That, of course, is just simply unacceptable. It cannot be, according to the evolutionists, and so they can get pretty creative in coming up with stories and explanations as to how to explain what we see. Got several minutes here. That's great. So, do you have any questions?
I just have
A comment, okay?
all those things that you said maybe it's a porcupine. No, I think that's their arrows. I think they really shot at that one.
That's a great, I bet it is. Yeah. It's still standing though. Yeah, no, that might be. I like that explanation. That's good. That's good. The arrows, the little white things are not hairs or spines. They're arrows. That's good.
Does the bird have the three holes in the head like a dinosaur that you said the sting?
No, a bird does not have 4 holes in its head. A bird has 3. Yeah, good question.
All dinosaurs considered cold-blooded.
There is controversy about that. I think there's a push to sort of have some of them be warm-blooded because then, they're more like evolving into birds and so forth. But there is some evidence that some of them, their bones are more porous. They're not solid like a bird. And that is an indication of warm-bloodedness, more porous bone. Their brains were amazingly small. And in fact, that's another really good point to discuss when we talk about birds and dinosaurs, and that birds are dinosaurs, because birds have just about the biggest brains, a much bigger proportion to their body size than humans. So that's another, I'm glad you brought that up. That's another major difference between birds and dinosaurs. They would have had to have then also evolved this gigantic brain real fast if they're dinosaurs. Yes?
So the term bird brain doesn't really make sense.
No, it ought to be dino brain. Bird brain does not make sense.
It seems like to me that the very definition of evolution, how, they're told, I mean, I've read in evolutionary books that, like scales on a fish that eventually became birds, somehow they transitioned from scales to feathers. And by the definition of evolution, is something supposed to progress better and better and better. Well, how did it get from scales to feathers when there's no transitional forms ever found
Right.
of the billions and billions of so-called years or generations that it would have taken
Right.
to so-called evolve?
Yeah, how did feathers evolve from scales? Well, the evolutionary proposal would be, okay, you've got the scales that dinosaurs have, and then they try to show different transitional forms of lizard-like creatures, dinosaurs, that have integument that's similar to down. So it's not a full-fledged flight feather, but it's sort of like a feathery thing. The thing is, we look at something and our brains can just make the connection. And so they go, okay, I can see how this would get from this to this. The thing is, that's not how it works. To get from this to this, you have to have the genetic information down in the DNA that then produces a protein, that then produces a shape that either is a hook or a barb on the feather, and then you've got to have two different proteins, and there's a lot more than just two of them that are all working together to form that structure that then forms a feather. So it's not just as simple as, oh, I've got this little sort of skinny, fluffy, almost scale-looking thing, and now I can imagine how it turns into a feather. Well, that's one thing, but go down into the molecules which are required for evolution to actually occur, and then you don't just imagine, oh, it'll just sort of smooge from this into that. You've got to have massive amounts of very specific information to make a protein, and other proteins that have to work with that protein. Everything's got to mesh together perfectly. And this is why I presented last year a talk on doubting Darwinism. Why, as we have come to the place now of understanding molecular biology as well as we do, evolutionists are abandoning Darwinism in droves because they recognize that natural selection, neo-Darwinism, cannot explain the origin of that kind of information to make a feather, to make a scale, to make a bone, to make an eye. So they're not jumping on a creation bandwagon, but they are literally admitting that natural selection does not explain how evolution happens. And so, as I pointed out before, the creationists are accused of not being scientific, of just believing what the Bible says without any evidence, without any research, without any explanation other than, well, God did it. A major portion of the evolutionary community have put themselves in an admitted position of saying, we don't know how evolution happens, but we believe it does. Now, that's a fact. And it's because of that very thing. It worked a long time to just sort of show, well, this bone, you can imagine how it turned into this bone, or see this feather. You go backwards and now it's sort of downy and then it's a thin little scale and whatever. Our brains can put it together, but not when you actually get down into the guts to understand what it actually takes to to make all these different structures. And evolution is in crisis right now. Yes?
Has there ever been any preserved dinosaur DNA they were able to look at? Or?
They're working on it because we do have soft tissue. The thing is, in my opinion, and lots of creationists' opinion, that DNA is still, few thousand years old, and so it's in pretty degraded shape. So it's going to be tough to, like they made it, say, oh, just put some frog DNA together with dinosaur DNA and you can make one in the Jurassic Park movies. It's not quite that simple. But they definitely are trying, and they certainly are trying, for example, to clone, to get the DNA from woolly mammoth. The thing is, you need more than DNA, right? I mean, just because you've got the DNA doesn't mean you've got a viable organism. You've got to have an egg. The egg is what supplies all the proteins, all the stuff to read the DNA. The male just presents his half of the blueprint. The female presents the carpenters, the bricks, her half of the DNA footprint, but she provides all the workers and everything else, all the materials. And so you've got to have an egg with the material in it that's going to work with the DNA from the sperm or from the cell that you got some DNA out of. And so that makes it really, really difficult. It was easy to clone. I say easy. The molecular hurdles were nothing compared to getting DNA out of a woolly mammoth or a dinosaur when they cloned a sheep. Because, I mean, they're both alive, so they just take an egg from a living sheep, enucleate it, take the DNA, mix them together, and put it in there. And, yeah, they cloned a sheep. They've cloned a lot of things. It'd be pretty cool. But, what are we going to use for an egg? We don't have any living dinosaurs running around. Oh, wait, we got birds. I forgot. Maybe we can use an ostrich egg, I mean, we laugh, but, I mean, they're telling you that birds are dinosaurs. And so why can't we just take an ostrich egg or a cassowary egg? You ever seen a cassowary?
Yeah.
Oh, wow, but the bizarrest bird ever. They're killers. They kill people. Yeah, so there's another dinosaur walking around. But anyway, we get these eggs from a bird that looks like a dinosaur, and maybe we can take the dino DNA and mix it together with the cassowary egg, and it's sort of silly.
I was reminded with the cave painting here, I saw they saw like a cave painting, and like, oh, that looks kind of like a stegosaurus. It's got like these weird circular patterns on it. And like, that's weird. It's some sort of, autistic flourish or whatever.
Huh.
And then they ended up finding like the stegosaurus skin. Like, there's a weird circular pattern on the skin.
Huh.
I wonder where that came from.
Yeah, that's cool. There are carvings of stegosaur, brontosaur, and then we've got these cave drawings. It's I'm not going to say it's common, but it's not incredibly rare to find these artifacts that demonstrate man and dinosaur coexisting.
Is it in Texas where I've seen pictures of like dinosaur footprints and human footprints?
Those are the ones you've probably seen, footprints of humans and dinosaurs together.
Right.
The ones in the Paluxy River outside of Glen Rose, Texas,
Right.
are well known. But again, those things are not that uncommon. I mean, that we find footprints, dinosaur footprints all around the world. And, just look at those Laetoli footprints. I mean, supposedly 3 to 3.5 million year old ash, and you got human footprints in them. So what's the problem? Not that humans were around 3 million years ago. Nobody thinks that. The problem is the dating techniques that they use to date the rock. And that is why then the soft tissue in dinosaur bone is so extremely important. Because how do they come up with this particular T-Rex was 68 million years old? Well, they find that bone in a rock that they've dated to be that old. So what's wrong? There's tissue in it, so it can't be that old. Well, then that demonstrates that they're measuring techniques, whatever they're doing is just simply wrong. But it can't be wrong because the whole evolutionary scenario, the whole story depends on, again, your imagination coming up with, well, if you give it enough time, I guess these things could happen, It's amazing how much the evolutionary theory depends upon your imagination. So little of it is based on hard empirical science. A little bit here, a little bit there, you make the connection. And then, oh yeah, that's logical, that makes sense. Just because something seems logical doesn't mean it's true. Yes?
As you kind of observe them over the years, discard one theory, go for the next crazy one. Where do you think they'll be in 20 years? And if the Lord tarries in his return, now that they're abandoning natural selection?
I think we can only move as a secular scientific community in one direction, and that's outer space. And that's already, it's already here. The idea that there's life in outer space and that life came here to Earth, because very few, I don't know what kind of percentage, I don't have access to that kind of information, but I would suggest that a small portion of the evolutionary community now is convinced that life could have evolved from non-life on Earth, straight out from chemicals. Living organisms, maybe bacteria, maybe Dicynodons, who knows, came from outer space, survived on a meteor or whatever on Earth, and then evolved from there. Or even aliens, aliens every once in a while. You've all seen good science fiction movies, right? Aliens every once in a while will seed a few new organisms on this wonderful, test tube planet. And it's all science fiction, but it won't be science fiction. And for a lot of people, it isn't science fiction even now. One of the things you might be prepared for is we're looking for life on comets. Comets are water, rocks. The hydroplate model, one of the creation models for what happened during the flood, actually proposes that given the great fountains of the deep exploding with such force, some of the surface of the earth, water and rocks and so forth, could have reached escape velocity, and that's not pie in the sky. It could happen. Reached escape velocity and went out, and that's why we've got all kinds of craters on the surface of the moon facing Earth. And you realize there's virtually no craters on the backside of the moon. There are some, but the side that faces Earth, and it's all the time, the moon doesn't spin like this on Earth. We only see one side of the moon. You know about that? They call it the dark side of the moon. There's very few craters on the dark side of the moon. Perhaps part of that explanation is material from Earth blasting and hitting the moon, and material from Earth blasting out into the solar system, becoming comets. Well, now, if that's true, and that's just part of the model, I don't know how much work can be done on that to demonstrate that. But if that is true, well, then there's going to be some life in those chunks of Earth that got blasted out into space. There are going to be bacteria, there might even be some plant material. Who knows what kind of stuff would be in that material. And one of these days, could be sooner than you think, we may manage to harvest some material off of a comet. And can you imagine when they find some bacteria or some algae or something on a comet? Well, what will the explanation be? That's where life came from. And it'll be powerful. It will shake a lot of believers when they don't understand, the possibility of that explanation or some other.
Where did that life come from?
Well, that doesn't matter. They've got 13 billion years out there to evolve. Okay, so we've only got 3.5 here. Yeah. So, but the explanation for life on Earth is out from outer space.
They can't give an explanation with stuff here, so the theories will now move to outer space.
Yeah. The explanation of how life why life is on Earth is that it came from outer space. That's why they're looking for it on Mars. Because maybe it started on Mars and then came to Earth, you know. They're looking and looking and looking for life on Mars. That gives them another, according to their dating stuff, another 500 million, another billion years. Why they think that's enough. But anyway, just keep moving it out. And I don't mean to be too sarcastic, but it is sort of convenient that you say, well, life evolved from non-life out there. We can't ever go there and look at it. So talk about being absolutely outside the bounds of science, but it'll be tucked in with all these scientific explanations. Well, it's about 5 after 8. Unless somebody's got a burning question, we'll take some more questions tomorrow evening. Probably be a good time to conclude. All right? All right, let me close in prayer. Lord, thank you for these amazing creatures that you've created. The birds, what an amazing animal that it can fly. The songs that they sing, they're so beautiful. And all these different dinosaurs, all these creatures, and your masterpiece, human beings. Not so much because of the way we look, but surely because of our abilities that reflect so many of yours. Thank you that you've also made us your children. We're not just a pet. You've made us your children. And I just want to thank you for that privilege. Along with it comes responsibility, Lord, because there's a lot of kids out there, I think, that you have chosen to adopt. And I just pray that you would help us continue to love those who are not so lovely, those who even hate us, and bring them into the family, Lord, for your glory and certainly for their good. I pray this in Jesus' name.
Amen.